Hello everyone, welcome to my tech channel. In the previous video we saw how to create a simple Hello World program and build it with Bazel. In this I will complexify the previous use case and create a library, and then my Hello World program will call this library. For this example I'm going to create a package which will hold the binary. A package is a file in the Bazel workspace containing a build file. So in the previous example, I created a build file inside my base directory, which is the one containing the workspace. This makes the base directory a package, but we can also have packages embedded inside of the workspace. So for this, I will create a new folder, which I will name hello. Let's call it pkg. That's going to be my hello package. And to make it a package, I will add a file, a build file we call, inside this. And then I will finally add my source code. I will call it hellolib.cpp, and I will make a header file just to make it a bit more interesting. lib.h, and then going back to my build file, I can already create my cc library which name will be hello lib. It will have one source file which will be hello.cpp. It will also have a header file which will be hello.h. Notice that I'm putting this into square brackets. This is because these are lists. There could be many sources and many header files, and there are no dependencies for now, since this library will be standalone and won't depend on anything else. That's it. So let's create class, say let's call it a greeter. So it's got a public method greet, and then okay, so now that we have this library, we can try building the library with Bazel. So in my build file I use the name hello lib. So we will do Bazel build / like in the previous example, except instead of having the colon here like in the previous example where we were simply building the target in our root, at the root of our workspace, we will first have to write the name of the package, which in this case is hello.pkg. This is the name of the folder in the workspace, and then a colon followed by the target that we are trying to build within this package, which in this case is hello lib, right here. This is because we're getting this error because in my I made a mistake in my CC library. The files are not really called hello.cpp and hello.h. They're called hellolib.cpp and hellolib.h. Now if we try to build it again, it succeeds, which means we have a functional library and we are ready to use it in our Hello World program. So we will modify now this Hello World program, and instead of printing Hello World, we will use our library, which will be hellolib.h, and so we will instantiate a greeter say greet. Let's call it greeter, it's better. Greet. And the question now is, how do we include this library in our program? So including it, the include statement is not sufficient because now Bazel does not know where to look for this file. So we have to go back to the file that we worked on in the previous tutorial and modify it a little bit. And we will add one dependency because now the Hello World program depends on a package. And then we will use the same syntax as I use when I issue the Bazel build commands. It begins with a double slash and then the name of the package, followed by a colon and the name of the library, the name of the package, the name of the so this is the package name and this is the target's name, and targets are items that are contained in build files. So this is a target, this is a target, the name is the name attribute, so in this case hellolib. So we're depending on hellolib, and I'm not expecting this will work. So if we try to build now the hello package that we developed in the first exercise, it is failing. We need to add the visibility attribute to our library because by default targets contained within packages are not visible to the rest of the project. To make them visible, you have to specify to which packages or targets they will be visible. In this case, I'm not going to make it specific. It is possible to set the visibility attribute so that a given target will be visible to anybody, any packages contained within the project, by setting the visibility to public. And this is done by setting this attribute to / visibility colon public. So the next reason it's failing is Bazel resolves the name of the includes with the package name. So we either have to specify the package name here, and in this case it should build successfully, but I don't like this because it makes it a little bit less modular. You would expect that people using this library won't necessarily have the same exact workspace, or organization of the folders within the workspace might be different. They might rename some packages or place them elsewhere, and so this will not make this exactly modular. So what I like to do is in my build file for my CC binary, I will include an attribute called include, and this will tell Bazel which directories to include. So this is a list of strings, and now we're telling Bazel to include any files within the subfolder hello package. So we do not need to have this anymore, and we can make it clean and modular. So it's still working. Okay. And by the way, I ran 2 Bazel commands so far in this series of tutorial, build and run. So build simply obviously builds, but that does not run the targets, whereas if I specify Bazel run on the command line, after building, the binaries get run, executed, and we can see the output on the terminal. And so this concludes this tutorial about adding libraries to a build. Thank you for watching.